samples can be, suppose in method of moments itself, if we have to equate the small m1 equal to expected value of x. If we have only one estimate, right? We have to estimate the only one parameter. The thing is, if you have been given the x1, x2, xn, values of x1, x2, xn, what you have to do? You will, you have to calculate that this m1 part. Okay, let me share my screen. Maybe is my screen visible to all of you? Can you see?
Yes.
Okay. Yeah. So what we have to do, what we are doing. So if you see, we need, if we need only one equation, let's say this is the part, right? So this x is what? This capital X. First of all, I'm saying this x1, x2, xn. These are the IIT samples from X. So this is the population part. This is the distribution information. Yes or no? So this says this x follows exponential lambda. So whatever the expected value of x, this is population's first population moment, right? So this is something you will calculate with the help of here. And this small m1, I told you this is the first sample moment, and this is something 1 upon a summation of x size. Okay. So this thing, this small m1, you have to calculate with the help of sample values. So this sample, this IID samples have been collected from where? This x only. Are you getting? So these are the sample. This can be any specific value also, right? And you have to equate these two. Let's say here itself. So you can say, suppose these are the x1, x2, xn till x6. These are the sample values: x1, x2, x3, x4, x5, x6. Okay, from some distribution with in the question it was mentioned it is from a distribution with unknown mean mu. Okay, so expected value of x is given to us, which is mu. What is the first sample moment? Is we have to find the estimate of mu only one parameter. So we need only one equation. One equation is enough to calculate the value of one unknown. So what you can do here, you can simply see we have to find the small m1. Small m1 is what? 1 upon n summation of x size. What is the each x size? This 210, 220, 225, 217, 210, 210. We have to add all this x size. We have to divide by n. That will give you the value of mu. Okay. Similarly, now let's say this one. We discussed yesterday this part also. So this is the information. Okay, this is the distribution information, right?
Yes, sir.
Okay. So what the expected value of x, this first population moment, you will calculate with the help of a. Okay. See, here there is no specific distribution, but you have been given the information x is taking these possible values and probability associated with each values, right? I mean, x will take value 1 with probability theta and 2 with probability theta and all. So I will calculate the expected value of x from here, and these sample observations have been observed for this scenario. Okay, so these are your x's. You will equate only one. I mean, you need only one equation, right? Small m1 equal to expected value of x, because you have only one parameter. What you will do? What is the small x? Small m1. So small m1 is 1 upon n summation of xi, because in general kth sample moment is 1 upon n summation of xi raised power k. So if you need m1 first sample moment, so it will be summation of xi raised power 1, that is xi only. You have to equate. So expected value of x will be from where? 1 upon summation of xi will come from there. Okay. So if you see for gamma distribution, we discussed about gamma distribution. You have two parameters. You have to estimate these two. Then we need two equations. Then we equated first sample moment and we equated the second sample moment also. All right. So with the help of these two, we got the value of estimate of beta as well as the estimate of alpha. So beta is we got m1 divided by m2 minus m1 square. So what is the m1? 1 upon n summation of xi. What is the m2? 1 upon n summation of xi square. So whatever the x's will be there, let's say 1, 2, 3, 3, 2, something like this. Okay. Then what you will do? You will add these observations, divide by n, you will get m1. And for m2, what you will do? You will square these. You have to square each values, and you have to do the addition of square of these values and divide by n. This will give the m2, and you have to substitute the values. Okay.
Yes, sir.
Okay, so let's try to solve some questions in today's slides. Maybe that will give you more idea about this methods. Okay. So this is
Yes.
the peer deck code. So I would request to everyone, please join it. So I will repeat the procedure. Just enter on your browser joinpd.com, and after that you have to enter the code. So code is TMGCEN. Okay. So I would request to everyone, just join it, and whatever the things you have learned yesterday and by the lectures, just try to apply it there. Okay. Do not worry about right or wrong. We will see the solution of each question stepwise. So please do let me know if at any step you have doubt or you are not able to join this slide part.
Sir, can you please share the link?
Link of what? Just on the browser, just write this joinpd.com. Just open your browser, either in your phone or system, whatever you have. Just write this joinpd.com. It will
Okay.
ask you a code. Yeah. The code is this TMGCEN. Got it? So this will help you to solve, I mean, this will give you some idea to solve the questions from GA also. Okay. So, okay. Should we start? Or if you are joining, we can wait for 1 or 2 minutes.
So, one small note.
Hmm.
There are some questions regarding confidence intervals in activity questions, later activity questions. Will that be included in the graded
No,
assignment?
that is after additional content, right? That
Yes,
is
sir.
not going to come in your exam. But thing is, I would suggest if you have time, please watch the lectures video related to confidence interval. It will give you the more no idea about
Understanding.
this. Uh,
Okay, sir.
yeah. Okay, so let me start. So I would request to everyone, please join it fast. Okay. So let me repeat the procedure once more. So this is the joinpd.com. Just just open your browser and just write this joinpd.com. Once you will write this, it will ask to enter a code. So code is TMGCEN. Okay. So this is week 9 solve the session. So very first question is, so you can say, like this, there is a very similar question in GA also. Okay, so this will give you two idea to solve the questions from GA also. Okay, so first question says let x1 x2 xn is IIT samples from a distribution X. Okay, and the information about distribution is with mean mu and standard deviation is sigma. Let mu hat is 20 times of x1 plus x2 plus I mean, so on till xn divided by n. This be an estimator of mu. You have to find the risk of mu hat. Okay. So there is one estimator is given to you. You have to check. You have to find the risk of mu hat. Okay. So first of all, what is the risk? How will you define the risk? The risk is what? It's a
Bias square plus variance.
bias square plus variance. So what you have to do? You have to calculate the bias and square it and find the variance and add the bias square plus variance. That will give you the risk. Okay. So you have to just type the option number. Let's say A, B, C, and D. Whatever the correct you will get. So I'm giving you 3 minutes, and please do let me know if you need extra time.
Done, sir.
Okay, great. Let's wait for others. Okay, anyone? Do you need extra time limit?
Done, sir.
No?
Done, sir.
Oh, great. So let me see the responses on your side. So C, 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 D, A, B, C. Someone has entered one. There may be option. Okay, then let's see which option is correct. Okay. So what are the things we have given? So first of all, we have information x1, x2, x till xn. This all are from IID xn. We have information that expected value of x is mu and standard deviation of x is sigma. Okay. So the thing is, if you have information like this, so what did so these all are IIDX. That means expectation of each x size is also mu, and standard deviation of each x size is also sigma, because these all are IID, right? The thing is, you have to calculate the risk. Whatever what is the estimator? So estimator is 20 times of x1 plus x2 plus so on xn divided by n. So we have to calculate the risk. So risk is, we know risk is nothing but bias square plus variance. That means if you will talk about like this, so risk of mu hat comma mu, and we have to calculate the bias in term. This is just a notation, plus we know variance of mu hat. First of all, we have to calculate the bias. Okay, so let's make it equation number star. So bias of how will you define the bias? This is nothing but expected value of the error. Error is mu hat minus mu, and it will be expected value of mu hat minus mu. Would you agree with me? And what
Yes.
is the expected value of mu hat? So it will be 20 times x1 plus x2 plus so on plus xn divided by n minus mu. Correct. So 20 by n you can take outside because these are we know expected value of a times of x is nothing but a times of expected value of x. This is something, this property we know. So if you take this expected value of x inside the bracket, so it will be expected value of x1, expected value of x2 plus so on, plus expected value of x of n minus of mu. And what is the expectation of each xi? It's the mu only, right? So it will be mu plus so on mu. This is minus mu. So if you see, this part will be 20 into 20 mu, right? Divided by n minus mu, correct? So it will be 400 mu. Uh,
Sir, it
correct?
will be n mu, na? Instead of 20 mu.
Is the calculation correct? Let me
Sir, it
check.
will be n mu, na sir?
Sorry, yeah, correct. This will be n mu. Yeah, thanks. That's why I'm thinking. So this n will get cancelled out. So it will be 20 mu. Correct? 20 mu minus mu, we will get the 19 mu. Okay. And what is the variance? So this is the bias part. So what is the variance? Variance of mu hat? It will be variance of 20 times of x1 plus x2 plus so on plus xn divided by n. So 20 by n is a constant, right? If you will take outside this, what it will be? Since we know, right, variance of a times of x is nothing but a square variance of x, correct? So by using this property, it will be 20 square, that is 400 divided by n square. And since all are independent, so I can write variance of x1 plus variance of x2 plus so on plus variance of x of n. Yes or no? So you can see from here 400 divided by n square, and variance of each xi is sigma square plus so on plus sigma square. So it will be n times, right? So n times sigma square, one n will get cancelled out. We will get 400 sigma square by n. This is variance. So what will be the risk? This is bias square plus variance part. Okay. So what is the bias? Bias is 19 mu whole square plus variance of 400 divided by n into sigma square. So square 19 square is nothing but 361 mu square plus 400 divided by n into sigma square. So which option is correct?
C.
C is the correct. You can see the possible error is given to you, right? 400 mu square and 400 and all. And if you will, by mistake, if you will not do this squaring, you will get option B and something like that. Okay. So is the idea clear? The method and the steps.
Yes, sir.
Oh, yeah. Yeah. So this is the solution, right? Solution part you can refer to it. The same thing we
Sir,
got.
can you explain bias?
So where you heard out bias part.
Yeah, yes, sir.
So bias is nothing but it's the expected value of the error. Okay. So error is what? The thing which you have estimated minus the original, right? So expected value of mu hat minus mu. So it will be expected value of mu hat minus mu. I mean this part. Okay. So what I'm saying, so expected value of mu hat minus mu. Okay, this is the bias defined. So this part I can write expected value of mu hat minus mu. Yes or no? Because mu is the constant. Okay, mu hat will be a random value. This is the bias part. This is called bias.
Yes, sir. Thank you.
The same answer we got. Okay. Okay. So question number 2 is based on maximum likelihood estimate of theta for the sample. So the information is x1, x2, xn are from IIT x, and x is the random variable with density function. Okay. So yesterday we saw some standard distribution, right? First we saw Bernoulli, then we had some other distribution also, right? You can see we discussed about Bernoulli, and then one part there it was in his, yeah. For this also we calculated the I mean, we estimated the value of P with the help of maximum likelihood as well as method of movement. Okay. Here f of x is given to you since this is the, what is it? This is continuous or discrete?
Continuous, sir.
Continuous because it's a PDF, right? We are talking
PDF.
about density. We are not talking about marks. Okay. So f of x is given to you, and sample from this distribution is taken as this. These 6 samples have been observed. What is the maximum likelihood estimate of the theta for this sample? Okay. What you will do? What will be your first step?
Multiplying the respective probabilities.
Respective probability. So what will be f of x, x1?
Theta by 3 to the
Power
power.
theta plus 1.
So I would suggest just do in general, and at the end you can substitute the values of 3, 6, 2, 7, 8, 10. Are you getting my point? What you can do, just write. I mean that will be a bit simpler for you. So what I'm suggesting, so just solve like this. So what will be the likelihood? Product of I is equal to 1 to 6, right? Fx of xi. Okay. Just do fx of x1 into fx of x2 and so on fx of x6. Just solve by this, and at the end you can substitute the value of each xi. Is this okay? Or whatever the you want to do, that's not a problem at all. So you have to first find the likelihood, and then you have to do the since we have to maximize the likelihood. So yesterday we saw maximizing the likelihood is same as maximizing the log likelihood. Okay, then you have to take the log of that likelihood function, and as usual the how to find the maximum of function, right? So you have to take the derivative, and basically you have to differentiate with respect to theta and equate with 0, and then you will get the maximum likelihood. Okay, so I'm going to give you 3 minutes. Please let me know if you need extra time.
Sir, one small doubt.
Mhm.
Should we take a log to the base 10 or log to the base e?
It's a natural logarithm.
Because in one question, in an activity question, they used a log to the base 10
No, it's a
so
natural
that the
log.
answer becomes.
Just go with the natural log. Maybe that there is some error or something we need to check. But
Okay, sir.
natural log is the best. Okay,
Yes, sir.
log with the basic.
Uh, Sir, in the place of x, we need to just keep x1, right, sir? In the place of fx of
Yeah, that's
x1.
the importance of fx. That's the meaning of fx of x1 into fx of x2, right? So
Yeah.
this is for one specific x, right? Then for 6 samples instead of x, so x is what? One sampling instance. So if you just, you can think instead of x, you have x1. You have to replace the x with x. Okay.
Yes.
So, do you need extra time limit?
Unable to solve, sir.
Anybody sort of, what about others?
Sir has solved, but don't know if the answer is.
Solved, sir.
Okay, is there anybody? Do you need extra time limit or should we proceed? Yes, no, anything?
You can proceed.
0.6, 0.605, 1.2, 1.2. Okay, let's see. So what is the very first step? We know first of all, first of all we have to calculate likelihood. What is the likelihood? We are interested to know what is the probability of observing your sample, correct? Now we have to, how many samples you have totally? Six, right? 3, 6, 2,
6 samples.
3, 6, 2, 7, 8, 10. Okay, let's do in general. I mean, this is x1, this is x2, 10, x6. Let's do in general. What is the f of x first of all? So f of x is defined as theta divided by x raised to power theta plus 1. Okay, so f of x is fx of x is theta divided by x raised to power theta plus 1, and theta is greater than, right? Sorry, x is greater than, because we're talking about random variable x. Now thing is, we have to do for this. What will be here for x1? Can I write theta divided by x1 raised to power theta plus 1? Yes or no?
Yes, sir.
Into theta divided by x2 raised to power theta plus 1.
Yes, sir.
And similarly till theta divided by x6 raised to power theta plus 1.
Yes, sir.
So what the things we are getting? Can I write
Or
theta raised to power 6 divided by, or else let's divide by theta 1 raised to power theta, sorry, divide by x1 raised to power theta plus 1 into x2 raised to power theta plus 1, and so on x6 of x6 raised to power theta plus 1. This is,
Excuse me, sir.
yes.
As these are IIDs, so can we write theta by x plus x power theta plus 1 whole power 6?
Okay, these are IID. What do you mean by IID? So this,
Independent
okay, so
identical distribution. Yeah.
I'm not asking about the full form. The thing is, see, here these are the one particular sampling instances, right? So my question is, so this is, see, this all are IID means, first of all, okay, let's start to understand. So what is the value of density at value when you are substituting small x? This is the part, right? Okay.
Yes.
You have to find the value of density when x1 is there. This will be part. So see, IID means it's from same population distribution, right? That, see, for different values of x, density will change, right? But it's from same. Are you getting my point?
Yes. Sir.
Okay.
Yeah.
So okay. So for these kind of samples, these are for these different samples. If values of the density will be same, different. But the thing is, it's from same population distribution. Let's say I'm saying x1, x2, xn have been drawn from normal mu comma sigma square, right? For each xi, mean is same, variance is same. For each xi has been drawn from the same probability distribution, that is from identical distribution, which is normal. But whenever you will apply the f of x, so which is 1 upon under root 2 pi sigma e raised power minus 1 by 2 x minus mu divided by whole sigma whole square. For different values of x, that this value of density will be changed, right? Now it's clear? So, yes or no? Is this fine?
Yes. Sir.
Yeah. So what is the next step? Since, see, now if you will take the derivative and all, it is going to be difficult for you. Yes or no? Then what is the good task?
Log.
Taking log.
Taking log, right? So if I will take the log, this is natural log. So what I can write? So I can write first of all log of theta raised to power 6. Okay. The next part I can I write? Okay, first of all, there is one more thing we can write, but let it be. Can I write minus of log of x1 is for theta plus 1 plus x2, log of x2 is for theta plus 1. Are you getting this part? Yes or no?
Yes, sir.
Right? Why I wrote minus? Because this will be this whole power minus 1, it will be minus 1, right? Now, if you see, this is something I can write 6 log theta minus the other things. If you observe here, can I write theta plus 1 log of x1? Yes or no?
Yes.
Theta plus 1 log of
X2.
x2 plus so on plus theta plus 1 into log of x6. Now, if you observe, so I can take common theta plus 1 or not.
Yes, sir.
Yes, sir.
What are the things is remaining? Log of x1 plus log of x2 plus so on log of x of 6. Another thing you can do right now here. So if you see the powers are same and accordingly you can adjust, right? But let's go step by step. Okay. So this is log of n. What is the next task? We got the log of n. We have to find the basically we have to find the derivative. So
Differentiation.
d of log l and d of theta, it will be 6 by theta minus, what should I write? Tell me.
Log x1 plus.
First of all, if you will differentiate this
One.
part with respect to theta, you will get 1, right?
One.
1 into some coefficients, right? So this will be log of x1 plus log of x2 plus so on plus log of x of 6. Yes or no? Any doubt?
Yes.
And this is something we
No,
have to equate to 0.
0.
So what you will get, I will get 6 divided by theta equal to log of x1.
Excuse me, sir.
Yes.
Can't we write log of x1 as 1 by x1 plus and so on, 1 by x6? As
Why?
we are differentiating
We are differentiating with respect to what? Are we
theta.
differentiating with respect,
Yeah.
right? So other things will be as a constant, right?
Yes, sir.
Okay, great. So here from here, what is the theta hat? 6 divided by log of x1 plus log of x2 plus so on plus log of x6. Okay. Now from here, so theta hat will be, what is the x1? You have to find the log of 3 plus log of
So,
some 6, 2, something like this. Yes.
so,
Hmm.
sir, can't we write the denominator as log of product of all the values? It will be direct, sir.
Yes.
Yeah, you can write. That's not a problem. Just I wrote. See, I did in stepwise so that it should be clear to you. See, you can do here also, but here how will you write? First of all,
We can take theta
I
plus
did
1
that
whole
in
power.
that step only, sir. That
Yes.
L equal to theta by 6. I did the same thing in the single
see,
step.
tell me. So here I can directly write product of I is equal to 1 to n xi raised power theta plus 1.
Yes, sir.
Right? 6. So if you apply the log, here it will be summation of log of xi raised power theta plus 1.
Yes.
I will get some summation of theta plus 1 times log of xi.
Yes, sir.
Theta plus 1 you can take outside
Mm.
and you will get summation of log of xi.
Yes.
Summation of log xi means log of product of xi.
Yes,
The
sir.
same thing you will get. I just did stepwise. That's not a problem.
Yes.
Okay, what's answer you will get? You got
0.6, sir.
yeah. So I'm not going to this. You can just substitute the values here. Okay, let me see what is the exact answer. So the same approach. So here in the PDF itself, so we did in general. First we started from the n only, and at last we substitute the value of n, which is 6, and divide by something. So answer is 0.60. Okay, so your answer is that's no problem. You can go stepwise like this also, or else you can do the directly. I did stepwise so that it should be clear. Okay, is the funda clear to all of you? See,
Yes, sir.
this MLE problem sometimes people find difficult, so that's why we kept most of the problem related to maximum likelihood estimates.
Sir, can we do like this? Suppose the sample is here given 2, 3, 6, 7, 8, 10. The value will be 2 by x to the power 3. Then for 3 x by x to the power 4. Then we put all this value like this.
Where you are asking in the beginning one?
Yes, in beginning one
Ah,
here.
you can do, you see, you can start something like that, theta divided by 2 raised power theta plus 1
Yes.
into theta divided by 3. That's not the problem at all.
Okay.
See, at the end we are substituting the values. Okay,
Okay.
that's not the
Actually, I
problem.
did the halfway, but after that I am unable
See,
to.
what will be your step? See, now what I will do, I will get theta divided by 3 raised power theta
Yes.
plus 1. No,
Yes. Yes.
6 theta divided by 6. So instead of x1, x2, x6, this value will be there. So
Yes.
at the end, I'm going to get this part, right?
Okay.
Okay.
Yes.
Yes. So just try. Maybe you are making some mistake. Just
Yes.
try once more. Okay.
Yes,
But
sir.
actually, I did this only, but
Hmm.
I don't know. I'm getting 1.39 actually, sir.
Maybe some calculation mistake you are doing. Yeah, just check once more. Okay. Maybe some calculation mistake.
I think he took log to the base 10.
Did you take log to base 10 or log base e?
I took log base 10, sir.
No, no, log base e. I told right. You have to take the natural log also. Yesterday
Oh,
itself.
sorry.
That's a natural log. Yeah, just go with the
I,
log base e, not log with base 10.
I missed
See,
out on.
so what's the usual thing? See, usually we should mention, but the thing is, if it's not mentioned, that means you have to go with the log base e. Otherwise, the base will be clearly
Mentioned.
mentioned, right?
Okay.
Okay, yeah. I mean, that's the mistake then. Yes. Okay,
Because
again, next problem is related to maximum likely good estimate of p. So this is now binomial 4 comma p. You have to find the value of p. Okay, suppose in case even n is also not given to it, then you need two equations with the help of method of moment, right? Suppose n is also unknown, then to calculate the two unknowns, you need two equations. Yes or no? Okay, that's the another.
Yes, sir.
Let it be. Okay, so you have to just estimate, find the estimate of p, and I'm going to give you 3 minutes. Please do let me know if you need extra time.
Sir,
Just
if there
like,
are two unknowns that we need to calculate in maximum likelihood, will it be possible?
sorry,
Uh, is there a chance that we can calculate two unknown parameters by using MLE?
that's what we
So
are
far,
doing.
we have
Two
calculated.
unknown. You are talking about two unknown. Are you
Okay.
talking about two unknown?
Yes.
Uh, that we can discuss. Okay. Just now focus for one more.
Okay, sir.
Yeah. Okay, so is there anyone? Do you need extra time limit?
Yes, sir. Yes, sir. Some more time, sir. Please.
1 minute or 3?
1 minute should do, sir.
Oh. Hello.
Yes, sir.
Yeah, do you need extra time or should we proceed?
Proceed, sir.
See the results. So 0.56 minus 6, 2.53, 0.56. Okay. Some varieties are there. So first of all, so we have x1, x2, x3, x4. These are all are IID from binomial 4 comma p. Okay. So if you see what's the information x1, x2, x3, x4, these all are ID from binomial 4 comma p. So what will be the your PMF here?
4C
So
X.
in general it's NCX, so it will be 4CX, right? P raised power x and 1 minus p
1
raised
minus
power
p.
4 minus
Minus
x.
X.
Correct? That's the PMF part. Okay, give me 1 minute. Okay, so what is the likelihood first of all? So likelihood will be product of I is equal to 1 to n. So we have 4. So fx of xi. Okay.
Yes,
So
sir.
do not treat this fx always as a PDF. So if your x is discrete, it will be PMF. Otherwise, it's a PDF. Okay. Now, so what else I can write? Fx of x1 into fx of x2 into fx of x3 into fx of x4. Okay. So if you see what will be fx of x1, it will be 4c x1 p raised power x1 1 minus p raised power 4 minus x1. Yes or no?
Yes, sir.
Similarly, 4c x2 p raised power x2 1 minus p raised power 4 minus x2
Yes, sir.
and 4c x3 p raised power x3 1 minus p raised power 4 minus x3 into 4c x4 p raised power x4 1 minus p raised power 4 minus x4. Yes or no? Now, if you observe clearly, so I can write 4cx1 into 4cx2 into 4cx3 into 4cx4. Yes or no? And p raised power, I can add all these powers, right?
Yes,
x1
X1
plus
plus X.
x2 plus x3 plus x4. Would you agree with me?
Yes,
Into 1 minus p raised power will be
4 minus
4 minus
X1
x1 plus
plus.
4 minus x2. So it will be basically 16 minus x1 plus x2 plus x3 plus x4.
Yes, sir.
Is
Yes,
this
sir.
clear? Is this steps clear to all of you? I did directly here. Is this clear? Because this 4 minus x1, 4 minus x2, this is 4, 4, 8, 8, 4, 12, 4, 16 minus of all this exercise. Yes or no? Is this clear? I mean,
Yes, sir.
is there any
Yes,
doubt,
sir.
right? Now, the next thing is, what is the values of each exercise? 2043, right? So we can substitute here. That's not a problem. So what is so this will be 4C2, 4C0, 0, 4, 3, 4C4 and 4C3, correct? And P raised power, it will be 2 plus 0 plus 4 plus 3. You can start, you can do from a starting step also. That's not problem. So 2 plus 0 plus 4 plus 3. So what else we get? So what is the 4C2? 4C2 is
6,
4C0 is
4,
4. 4C4 is 1.
1,
4C3 is
4,
again 4.
4.
Right. So you will get there 6, 4, 24, 24.
Oh, sir, 4C0 is 1, I think.
Yeah, 1. It's 1.
4C0 is 1, sir.
Yeah. Sorry. 4C0 is 1. 4C1 is 4.
Yes, sir.
Okay. So this will be P raised to power 9 and 1 minus P raised to power 16 minus 9 will be
7.
7. That is this clear till now? So we got likelihood
sir.
as a 24 into P raised to power 9, 1 minus P raised to power 7. Now what is the next step? You have to take the log.
No,
So it
naturally.
will be log of 24 plus log of P raised to power 9 plus log of 1 minus P raised to power 7. Right? Then it will be log of 24 plus 9 log P plus 7 log 1 minus P. Correct? Then what is the next step? I have to take the
DP.
now with respect to P. So this is the constant, it will be 0
Is
and here I will get 9 by
9,
P and this is 7 divided by 1
1
minus
minus
P. But again you have to differentiate 1 minus P, it will be
minus
minus
1.
1 equal to 0. Now the next task is 9 by P. I can write equal to 7 divided by 1 minus P, right?
Yes, sir.
It will be 9 into 1 minus P equal to 7 times of P. So it will be 9 minus 9P equal to 7P. So from here you will get 9 equal to 9
16p.
16P. So P hat equal to 9 divided by 16.
16.
So what is the value of 9 divided by 16 basically?
0.5625.
Yeah, whatever. Yeah, something 0.5625. So this is the answer. Okay, is the idea clear now? Yeah, you can say the same way we did discuss. So 9 by 16 is the correct. Is the idea clear to everyone?
Yes.
Okay, then again, there is another question. You have to find the bias. So consider the sample of IID random variables x1, x2, xn, where n is greater than 30. That is something large sample. With each, expectation of each xi is mu and variance of xi is sigma square. The estimator of mu is given to you as a 1 upon n minus 30 summation of, and summation is going from I equal to 31 to n each xi. You have to find the bias of mu hat. So how will you calculate the bias? What is the idea? So bias is what? Expected value of mu hat minus mu, right? Here mu1, correct? So you have to calculate the expected value of mu1 hat. So I'm going to give you 3 minutes. I would expect from everyone, so whether it's correct, correct answer from everyone. Okay, so do you need extra time limit? Yes, no?
No.
Done, sir.
Okay, yeah, this is 4 responsive 0001. Okay, so let's see. So what is the mu hat? So these all are x1 up to xn, okay, with each xi is mu and variance of each xi is given to you. Sigma is square and estimator is given to us as a 1 upon n minus 30 summation of I equal to 31 to n xi. You have to find the bias. So we know what is the bias. Bias of estimator is nothing but expected value of mu1 hat minus mu, right?
Yes, sir.
So what is the expected value of mu1 hat? So it will be 1 upon n minus
N minus
30
30.
summation of I is equal to 31 to n xi minus of mu. Now 1 upon n minus 30 I can take outside and it will be summation of I is equal to 31 to n expectation of each xi minus of mu. So what it will be n minus 30 and it will be we have to add uh, mu, right? It will be mu plus so on, right? Basically it will be mu only, correct? Basically each xi. Okay. Now you have to tell me what will be the value. How many times mu is occurring?
N
N
minus
minus
30.
N minus 30, right?
Yes, sir.
Yes or no? So because if you see, if you add like this, let's say mu plus mu, or let's think like this, x1 plus x2 plus so on, plus x30 plus x31, x32 plus so on, xn. Okay. So we are adding from here to here. What is this? If total is n, okay, total is n, and this is the 30, and we are subtracting, this is n minus 30. Yes or no? Or smartest approach is that is one trick. Maybe you all are aware about it. If you want to find the number, so just do the upper one minus lower one and add one. So it will give you the exact. So it will be n minus 30. You can try anything. Let's say summation I going from 6 to 9. How many things are there? Usually they will find as a 3 only, right? But that's not correct. Total is you have to do the summation 4 times. How? 9 minus 6 plus 1. So it's a okay. So the next thing, so if this is n minus 30, so we will get n minus 30 times of mu, right? So it will be, erase these things. So it will be n minus 30 times mu divided by n minus 30 minus of mu. So this will get cancel out. So we got mu minus mu, which is 0. So
Zero.
bias is 0 for this. Okay.
Yes, sir.
Okay, so you can see bias is 0. That is next question. Again, maximum likelihood estimate you have to find this for this problem.
Answer is 0, right, sir?
Answer is 0, yeah. Bias is 0. That is unbiased estimate. Okay. I'm going to give you 3 minutes since we have solved some problems related to MLB. Okay, so please use the same concept and solve it. And please do let me know if you need extra time. Okay, well, do you need extra time limit?
Yes, sir. Yes, sir.
Let me give you 3. Okay, so anyone, do you need extra time limit? Or should we proceed?
Can you give 1 more minute, sir?
Oh, okay, all right, no problem. Okay, anyone, extra time or should we proceed?
May proceed, sir. Problem
Oh,
solved.
no, let me see some responses, some different answers, some random answers. So one good approach is, so whenever you are solving like this problem like this, okay, just go with in general and at the end, whatever the estimate you are getting, just substitute the value at the end. Okay, sometimes in between, suppose you are writing 10 or 15, sometimes by mistake you wrote something else and you will get something different answer. So good way to go with in general. So what is the f of x? Oh, by the way, what kind of distribution is this?
Sir, exponential.
Okay, so this is minus x divided by theta and x is greater than 0. It will take value 0 otherwise, right? So what will be the likelihood? Let's try to do in general. So it will be I from 1 to n fx of xi. So this is nothing but product of I is equal to 1 to n 1 upon theta e raised to power minus xi divided by theta. Yes or no?
Yes, sir.
Now, if I will, you can clearly say I can write 1 upon theta raised to power n.
Yes.
And e raised power, if you'll write like this, the product of I is equal to 1 to n e raised power minus xi divided by theta. So this means what? 1 upon theta raised power n into, this means e raised power minus x1 divided by theta into e raised power minus x2 divided by theta and so on e raised power minus xn divided by theta.
Yes, sir.
What's the case? Can observe, I can add the powers, right? Minus 1 by theta and summation of xi.
Yes. 1 to n.
Yes, sir.
Yeah, right? Is this clear till now?
Yes, sir.
Now, the next is, this is likelihood. So what will be the log likelihood? So log likelihood will be, this will be, okay, first of all, this is something I can write theta raised power minus n into e raised power minus summation of xi divided by theta. Correct? From here, I can write log of theta raised power minus n plus log of e raised power minus summation of xi divided by theta.
Yes, sir.
And this is something I can write minus
Minus.
L log theta.
Excuse me, sir.
Yes,
Can't you write 1 by theta per n as 1 by theta whole per n?
the same thing is there, right?
Yes, sir. Yeah.
See, if you are writing 1 by theta raised power whole, and that means you are saying n log of 1 by theta. Again, log 1 is 0 minus n log theta, right?
Yes.
So this is the case. So you know log with base e and e raised power something, this is nothing but x only, correct? The
Yes,
same
sir.
property we have used here. So this is log of n. What is the next step? I have to differentiate with respect to theta. So this will be minus n of theta. And here, what you will get?
Plus summation xi upon theta square.
Correct? Gauss inverse, so differentiation of 1 upon x inverse is nothing but minus 1 upon x square. Correct? So it will be minus will be plus. This will be summation of xi theta square. Would you agree with me? And this
Yes.
is something we have to equate to 0. So what else we will get? Can I write n by theta equal to summation of xi theta square? So
Yes.
what is the value of theta? Basically, you will, can I write n equal to summation of xi divided by theta? And I can write theta hat is nothing but summation of xi divided by n. Yes or no? And what is now what is the meaning here? You can see this is the average only, correct? What are the sample values? So 15, 16, okay, 10,
10, 8, 7,
8, 7, 9,
9, 20, and 19.
20, and 90. What you have to do? Just basically you have to add all this and divide by how many observation is 8.
8.
This will be 15 plus 16 plus 10
108 by 8.
104 by 8.
Oh, sorry.
divided by 8. So 104 divided by 8, that means 13.
13.
So 13 is the answer. That's all. Is this clear now?
Yes, sir.
So you can see the same approach, and at the end you will get the 13 as answer. So last slide is very interesting slide actually. So thank you slide to all of you. Okay, so is the idea clear? The approach to solve the questions related to this maximum likelihood and bias and all.
Yes, sir.
Okay, how many of you covered the lectures or is still going on?
Going on, sir.
Going on. So did you get the idea? Now you are able to understand the lectures, or
Yes.
are you able to solve the activity or PA?
Yes, sir. Able to approach.
Okay, okay, great, great. I'm assuming then if you are able to do, is there any doubt from AQ or something else, or is that fine now? I think yesterday we saw some questions from AQ also, right?
Yes, sir.
Yes, sir.
The same approach you have to just keep the basic steps in your mind and just solve that. Okay. Anything else? Anybody?
Excuse me, sir.
Mhm.
Yes, sir. I just have a suggestion.
Mhm.
While solving the activity question, if I stuck in any questions, I search the solution in discourse. Okay.
Mhm.
So in this course, for same problem, I got 2 to 3 different solutions in the same. So is it possible to include all the activities solutions to some space in
See,
this course?
yes, so that I got your point. See, activity is just to we are not providing the solution just because
Hmm.
of you should try something, right?
Hmm.
And also it's based on just for that
Basic
particular
thing.
lecture video, right? See, even
Yes, sir.
if you have any doubts, what you can do, whatever the
Hmm.
approach you are doing, okay,
Hmm.
let's say you are getting incorrect answer, for example, okay, what you can do, just share your approach on this course, you can tag to us, this is the my approach where I'm getting wrong, then we can
Okay.
check and we can let you know this is I mean in this particular step you are getting wrong, then you will get to know, yeah, this is the mistake you are making, okay. So you
Okay,
can,
sir.
rather than asking the solution, it's better to share our approach also, so that we can know, we should get idea. Okay, this I mean in this step or at this step you are making the mistake. I mean you are making some error and all.
Hmm.
Okay,
Okay,
that will
sir.
be great
Okay.
for you as well as for us. Okay,
Okay, sir. Okay.
all right. Yeah,
Yeah. Thank you, sir.
thank you. Okay, okay. Is there anything else? No.
Thank you, sir.
Okay. Thank you. Thank you all.
Thank you, sir.
Bye.
Thank you, sir.
Thank you. Bye.
Thank you, sir.